What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our Chapter 7 test review. We're doing this over 2 days, but I'm going to have both Part 1 and Part 2 in this video, so you can pause or skip forward to wherever you need to go. For the first three, we're going to just talk about your interior angle measurements of all the angles. For a quadrilateral, that means it is four-sided, so I'm going to do 4 minus 2 times 180. That's going to give me 360. For a 13-agon, that'd be 13 minus 2 times 180. That'll give me 1,980. And then for a 20-gon, 20 minus 2 times 180 equals 3,240. In this case, we won't have to do anything else, only when it's asked for specific interior angle measurements of each. For number 4, I want to find the value of x. Before I do that, I need to count how many angles I see. 1, 2, 3, 4, 5, 6. So this is a hexagon. And I gotta know how many angle degrees are in the hexagon, so I'm just gonna do 6 minus 2 times 180, and that's gonna give me 720. So I know if I take x plus 120 and 97 and 130 and 150 and 90, I'm gonna get 720. These numbers added together will be 587, and then I'm just finding the leftover amount, which would give me 133. The next one, a very similar one, except this time I have 1, 2, 3, 4, 5, 6, 7. So this is a heptagon. So first I need to figure out how many degrees total should I have. So 7 minus 2 times 180 is 900. So I have 2x and x makes 3x plus 160 and 125 and 110 and 112 and 147 equals 900. For all of these numbers that I added together, since I've already combined my x's like terms, I'm gonna get, oops, I didn't write that one down. 160 plus 125 plus 110 and 112 and 147. I'm gonna get 654. Then I just take my 654 and subtract it to see how much remaining I have. So 3x is equal to 246. And then finally divide, I get x is equal to 82. Okay. For number 5, this is when we're going to have to do some extra work. Find the measure of each interior angle of the regular polygon. So I'm going to do 30 minus 2 first times 180. This number is going to give me 5,040, but then since I have 30 angles, I need to divide by 30 to get per angle, and I'm going to get 168 for the interior. For the exterior, I just take my 360, because all exterior polygons have 360 degrees, and divide by 30, and I will get 12. Next up, we have an octagon. That's an 8-sided figure. So again, we start the same way. 8 minus 2 times 180, or 6 times 180, I'm going to get 1,080. Then I'm going to divide that by 8. Since there are 8 regular angles, I'll get 135 for each of my interior angles. For exterior, take that 360, divide by the number of angles, 8, and we will get 45 degrees for each exterior angle. Up next, we have a parallelogram labeled LM and Q, and we want to just find the measurements here. So MNQ is this big angle here, and if it's a parallelogram, it's going to have an opposite congruent angle, so MNQ is equal to 100 degrees. LQN is this entire angle here, and because it's a parallelogram, my 2 consecutive angles should be supplementary, so LQN would be equal to 80 degrees. QML would be this angle right here. I know this is a parallelogram, and I could use the transversal theorem right here for alternate interior angles. 29 is the alternate interior angles to QML, so QML is also 29 degrees. LM's length is 13, LQ's length is 8, QP is the midpoint being bisected by the diagonal, so that would be 8.2. And then NL is all the diagonal, and that's 7 plus 7, which would be 14. Number 15, I just stated the reasons here. I didn't necessarily go into theorems, so reasons are fine. Theorems are great too. With this one, this is a parallelogram because I have opposite sides are showing that they're congruent. For number 16, yes, it's a parallelogram because my diagonals are bisecting each other. And number 17, yes, it's a parallelogram because I have my opposite angles are congruent. Okay, this will conclude part 1. I'm going to go and move on to part 2. So if you don't need part 2 yet, you can go and end the video here. But let's go ahead and get started and talk about part 2. So for number 18, I'm trying to figure out what x and y are equal to. For my x's, 5x minus 4 equals 10x minus 24 since there's diagonals bisecting one another. And my y's, 3y plus 9 does equal 2y plus 16 since those diagonals are bisecting one another. For my x's, I'm going to get all my smaller x's, move it to the one side, and then move my constants to the other. So I'm going to get 20 is equal to 5x, where x can be equal to 4. For my y's, I'm going to move my smallest y and moving my constants to the opposite side. So I get y is equal to 7. Up next for number 19, again, finding x and y. I'll start with y's here. 2y plus 8 equals 3y minus 4 since opposite sides are equal. I'm going to get my smallest y's together, moving my constants in the opposite direction. So for y, I got 12. And then for my x's, 3x plus 25 equals 5x minus 5 since those are opposite congruent angles. Subtracting 3x from both sides, adding 5 to the other side, I'll get 20 is equal to 2x, so x has to be, 30 equals 2x, so x has to be 15. Okay. Onward, give the most specific name for this special quadrilateral, explain your reasoning. We call this a rhombus since we can see that there are 4 congruent sides. I can't call it a square because there's no 90-degree angle here. For number 21, this one I can just categorize as a parallelogram because I see 2 pairs of parallel sides. Okay. For number 22, again, give the most specific reasoning. This one would be a square because I'm seeing all congruent sides and I'm seeing 4 90-degree angles. 23 might have taken you a little bit of time. It is helpful if you graph this, and 9 does go a little bit over the graph, but we could do a good job of estimating. So I got point J here, point K is at 9,6, I'm going to estimate right about there. L is at 7,2, and M is 3,4. And I just want to know if this is a rectangle, rhombus, or square. So what I can do is just focus on 2 sides. And my 2 sides I'm going to focus on are over here on the right. I'm going to find the slope of JK and then the slope of KL first. So JK, I go down 1, 2, and I'm over going 1, 2, 3, 4. So that's -2/4 or -1/2. And then KL, I went up 1, 2, 3, 4 over 2, or just 2, and these are perpendicular slopes. So that means this angle right here is a 90-degree angle, okay? So already, I'm probably gonna say this is a square just because it's looking like a square. I'm gonna check one more thing, and that'll be my distance of both of those sides. So let's start with distance of JK. I'm going to use my x points here that were listed for me. JK would be 5 minus 9 squared plus 8 minus 6 squared, or 4 squared plus 2 squared, or 16 plus 4, which is 20. And I'm going to leave that in square root form just because it's not a perfect square. Then I'm going to find the distance of KL. KL, I would do 9 minus 7 squared plus 6 minus 2 squared, and you're still going to get square root of 20. So because I have a 90-degree angle and equal, two sides that are equal, that are right next to one another, I'm going to say square due to the 90-degree angles and 4 congruent sides. Okay? Next up, same type of deal. So let's go and plot points first. 5, 1, so 1, 2, 3, 4, 5, up 1. 9, 6, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. Q and P. We have 5, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for letter R, and then 1, 6, 1, 2, 3, 4, 5, 6 for letter S. Again, it's looking like it could be a rhombus or a square. I just got to double check my angles. I'm not drawing this perfectly with lines. You probably can do a better job of that. Same thing, I'm going to start with slope. I'm just going to pick two sides. I'll start with PQ. PQ is up 1, 2, 3, 4, 5 over 1, 2, 3, 4. And then I'm going to do QR is down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So this is negative 5 over 4. So this is not perpendicular / 90 degrees. Okay? The next thing I just want to check on is distance. So far I probably am going to guess rhombus with this. Distance of those two, we need to make sure. Starting with PQ, I'm just going to take my coordinates from above. P minus Q. So I'm at 5 minus 9 squared plus 1 minus 6 squared. This will be 4 squared plus 5 squared, or 16 plus 25, which is the square root of 41. And then I'm going to find the distance of QR. Q minus R, we've got 9 minus 5 squared plus 6 minus 11 squared. That'd be 4 squared again, which is 16, plus another 5 squared, 25, still square root of 41. So since they have congruent sides, we're going to say rhombus, since we have 4 congruent sides. No right angles though, okay? As we continue here, this one's another rhombus, so we're just going to talk about some things here. Remember with rhombuses, their diagonals are intersecting at 90 degrees, so I did add this in here to help my brain just a little bit. CM is a bisector that's going to be equal to 12. DM is going to be equal to 16, because that's the other side of my bisector. MAD, so MAD is here, and with a rhombus, your bisectors are angle bisectors as well, or sorry, your diagonals are bisectors. So MAD's angle is 53 degrees. AMB is this middle angle right here, and that one's going to be 90 degrees. Okay. ABM is where you can maybe use your knowledge of triangles. I did 53 plus 90 first, and then I got my 143. Then I'm just going to take 180 and subtract 143. So for ABM, I got 37 degrees. And then for ABC, again, this is the entire angle here. So one thing I could do is take, I know this is 37, so my other side should be 37 as well. I'm going to get 74. Okay. 31 talks about mid-segments. For trapezoids, you're going to add your legs together, or sorry, your bases together, half it, and that'll give you your mid-segment. So half of 10 plus 16 will give me my x. That'll be 26 cut in half, which is 13. For number 32, it's just going to work backwards. 1/2 of x plus 12 will give me 10.5 as my mid-segment. I'm going to distribute my 1/2 first, and then subtract 6. So I'll get 1/2 x is equal to 4.5, and then x would be equal to 9. Last few questions, we've got some kites here. With a kite, I know that these two should be matching. So 2x plus 100 plus 40 equals 360, since it's a 4-sided figure. So 2x plus 140 equals 360. Subtracting 140 from both sides, my remainder to split between those two is 220, so x is 110. And then for my next kite, I know this is 135, so x is just my mystery, so x plus 135 times 2 plus 55 equals 360 again, or 325 plus x equals 360. My leftover amount is 35 degrees. And finally, an isosceles trapezoid has matching consecutive angles on the base and on the bases, so C is 110 and D is 70 degrees. Thank you so much for hanging in there with me for this Chapter 7 test review. Hopefully this helps you just kind of get a general overview of what we'll see in our Chapter 7 test. And good luck on your test tomorrow. Have a great day, and we'll catch you next time.